Hello, my dear friends. Today we are going to work on how to create a CAPTCHA image. Here we have a blank canvas. So first of all, let's assume that we have the text that we want to convert into CAPTCHA image. So if we have the text, then it is a very systematic process, and I will explain step by step how to convert that text into CAPTCHA. So first of all, suppose we have a text with 5 or 6 characters. So our first step is to divide our image into number of sections which are equal to the number of characters. So we have 6 characters and we have divided our image into 6 sections. Then for each section, we would apply some different transformations to the text. So first of all, we might change the size and the Y position of each character in that section. Then we might also give some distortions. So first of all, this is like a sine wave distortion. We might give this kind of distortion to a character. We might give rotation to a character. We might give some skew and rotation, both effects to a character. And this is also, we can also skew some characters. So this would make the characters non-uniform, and this will introduce some variation in the characters, but it would still be readable by a human being. It would be increasingly difficult for a machine to read these characters. After that, we have two more layers. First layer is a noise layer, which is linear noise. We are adding some lines randomly here and there. And this is to throw off the machines, because machines would try to consider these pixels as a text, but these are not text. And then finally, we have some dot noise as well. We would add this noise in our capture image so that it is also becomes increasingly difficult for a machine to be able to decipher our text. So for a human, this is very simple and understandable text, but for a machine, this would not be understandable. So this is our scheme. This is our plan for creating an image-based captcha. And now we would just start implementing this in our Java program. So here we are in our Java coding environment. And as we have seen, the technique how to generate the captcha. So first of all, we would start from generating the text part of the captcha. Then we would get that text and render it into a proper image. So first of all, for that, we need some parameters. First of all, we need captcha length. And for now, we are giving six characters. We are creating a 6 character long captcha. And then we need to have a string which we would call captcha text. And for now, it would be empty. We would generate this image automatically. And for generating that captcha text, we have a small criteria. We would only be using alphanumeric characters, which were capital alphabet from A to Z, so small alphabet from A to Z, and numbers from 0 to 9. So only these characters would be a part of our captcha text. The other symbols and other characters, we are not going to include them in our captcha text. So this is these two parameters we need. And then we also have to write a new function, which we would call, we don't need to return anything. We would just call generate text captcha. So this function, when we would call this function, it would generate a captcha text, and it would generate some symbols, and it would append them into the string. So we need this function. So before we start working on this function, we need something, two helper functions. The first function that we are going to need is we need to generate a random number between a specific range. So for that, we have this function. Let me quickly add that function here. So this is basically Java's random is basically Java's given class to generate random numbers. So with this function takes in minimum and maximum value in which we want to generate a random number. So this is a very helpful utility function for us. Then we also need to have another function which tries to simulate a chance. So, for example, we want to simulate a probability of getting random text for here in our generate text. We have to have 33% chance of getting uh, capital alphabet character. Then again, 33% chance for a small alphabet character, and the remaining probability, which is 33.33 or 34%, the remaining chance of getting a number from 0 to 9. So this is our plan. There chance of getting a small alphabet character, uh, and again 33% chance of getting a capital alphabet character. So this is our plan. So in order to simulate a chance, we have another utility function which we would use. So for that, we have this utility function, chance. So in this, we get a random number and we also input the percentage. And if our random number is within that percentage, then it means that we are getting that probability. So these two functions, we would use them to generate a text-based CAPTCHA. So for that, we also need to uh, let's see what else we need. So we need these two functions to generate our string-based CAPTCHA, and we are going to use uh, a class which is called string buffer. So this string buffer class basically has a string, and whenever we append a new character into this string, this would the string buffer is basically used to create a string which is mutable basically. Generally, JavaScript strings are not mutable. What this means is whenever we change anything in a string, then Java creates a new string and replaces old string whenever we make a single change. So basically, this string buffer is used to store the strings efficiently. We can make changes to a string and it won't create a new string. It would just update the current string. So this is only reason that we are using the string captcha. And then we have to initialize a random number. So we just call random and equal to new random. So this just initializes our random number generator. So this is basically initializing it. Then we have to run this loop. So we would just run this loop I equals to 0. I is less than uh, our captcha. Let's copy that variable. So we have this variable captcha length. So let's copy this here. So it has to be less than captcha length and I plus plus. So it would just run till we have it would be then this loop will run for 6 iterations. So we would create 6 characters for our captcha. So first of all, we have the 33% chance of getting a capital alphabet. So we just simulate this chance by calling this function chance, and we would pass this random number, and we would pass the percentage, which is 33. If in our first attempt we get this chance, then we also have to initialize one more thing here. Uh, basically all the characters integer values. So we would just character number. We will initialize this with a -1, and whenever we hit our chance, we would just update this with some value. So what would that value be? Now we in when we are here, we need to generate a capital alphabet. So what is the how do we generate a capital alphabet character? So we for this we have to take a small detour, and we have to see how ASCII characters work. So let me quickly navigate towards some nice ASCII table, and let's see how this goes. Okay, so here we are. As we can see, this is a generic ASCII table. ASCII table is basically a coding standard, and which all the programming languages follow. So if we want to generate certain symbols, there are ASCII values. The character number is basically that value. So for our in our case, we are trying to generate capital alphabet. So for capital alphabet, the ASCII range starts from 65 to, and it 65 number is capital A, and 90 is small capital Z. So we have for capital alphabet, we have range from 65 to 90. So let's quickly go to our code, and let's define this range. So let's come here, and where we defined our CAPTCHA properties, let's define this as well. So our capital ASCII uh, capital ASCII start would be uh, 65, as we have seen in the ASCII table, and similarly our capital the better name would be capital ASCII alphabet, because we are talking about the only the letters. So let's give it a proper name. And the end would be 90. So as we have seen in this. So this is the range for our capital. Similarly, let's define the variables for small and numbers. So we would change this to capital to small ASCII, and we would give them values after reading them from table. Don't worry. Then we have to define uh, number ASCII start and number ASCII end. So we need these variables to define our ranges. So let's get back to that ASCII table, and let's see what is the range for small alphabet. So small alphabet starts from 97 and end at 122. So let's quickly add this to our Java code, 97 to 122. So here we would add this 97, and it ends at 122. Similarly, for numbers, we start from 48 and it ends at 57. So let's cross verify it. Uh, Here we can get back, and we can see that the numbers start from 48 and end at 57. So now let's get back to our code. So we have defined these ranges. We would need these ranges in our code. So here now we have all the tools that are needed to determine uh, the correct characters. So if we hit the first probability, then we just need to call this function generate random number in range. And for capital alphabet, we have first of all we will call a random number. Then the minimum value is capital ASCII alphabet start, and then I think I misspelled something. Let me check that. Let me copy the correct name. Capital alphabet. Okay. Let me quickly put it here. So this is our capital alphabet start and capital alphabet end. It would come here. So in this range, okay, let me check what is the problem here. Let me see if we have copied the name correctly. So let me go back and let's see what's the problem. So we have put it here. Okay, now it's correct. So this is our first chance, and then we would use the similar approach here. And instead of using if, we can use else if. So if our first probability wasn't fulfilled, then we need to come here and generate small alphabet. So small, for small, we need to just change this to small. And we if that is not the case, then the remaining probability would be for numbers. So just generate the numbers. So here we would generate, let's copy the correct name for the range. So first of all, we have this number ASCII start and number ASCII end. So let's copy this here, number ASCII start and number ASCII end. So by using this convention, we are successfully generating a random character, which is either a capital alphabet, a small alphabet, or a number. And we are distributing our probability equally. After we have got this character, we just simply append this to our string captcha. So we would just say append this character and convert this number. This is integer currently, so we would convert it back to a character and we would append into string captcha. Then when this is over, when this loop is over, we would just need to assign this string buffer to actual captcha text. So let's see, we have what's the name of our variable. So we have this captcha text. So let's copy this, and we would need to assign this string captcha, and we would convert it to string. So this would convert our current string buffer to string and assign it to captcha text. After running this function, generate captcha text captcha, we would get captcha text. So let's see if we can show this. So in order to see this in action, we have to modify this code a little bit. So instead of doing this, let's comment this out. Instead of doing this, we need to now have a condition. So let's say if we have this command, if we get this command and it equals we can use our captcha generator to captcha generator dot generate captcha button. So it was GB command. So if this equals to our GB command, then we have to. So if we press our if we have pressed our generate captcha button, then we have to show. Currently, we are not going to generate an image because we have just generated the text. So we need to show the text in our G option pane. So let's copy this and let's paste this and let's change this and let's show the actual generated captcha. So we would just call this captcha from captcha generator dot captcha text. So this would be displayed here. So let's prepend some text in order for us to understand it properly. So we would just say generated captcha text is equal to this text. So we would show this here. So let's see if this works. Let me quickly run this. And let me check. Let me see if this works. Okay, so we were just checking the text, but we didn't even call this generate captcha text. So we have to call this whenever we hit this button, generate captcha, we have to generate text captcha. Then we would show that captcha in our dialog box. So let's run this, and let me share my screen with you. So as we can see that we are here, and when we hit this, we can see that we have generated a random text. This is 6 characters long, and if we hit OK, then it will be closing. It will close, and then if we hit on this button again, then it would be another random text which is generated. So if we generate it time and again, we would see that different kinds of text is being generated, but it is all random, and it has numbers, and it has small and capital letters the way we intended it to be. So this is working as expected. So our first part of the puzzle is solved. We have successfully been able to generate a random text based captcha. So our text captcha is complete. Now we would start working on generating image captcha. Okay, so now we are going to implement image captcha. So let's see how we go about this. So first of all, we have to write this method, which is called generate image captcha. So in this image captcha, we need that text which we generated. So let's call this text. And for now, this is going to be our method. And in here, we would step by step generate an image captcha. So for starters, first of all, we need to get the images dimensions, which we already have those dimensions here. So for our captcha, we have our captcha image width and height defined here. And let's start from there. So let's have our let's define local variables. Width is ci width, and height is ci height. Captcha image width and height. So we have defined these variables. Then we have to create a new image. We call this buffered image, and we have to get the graphics context. So let me quickly start from that. So here we are going to initialize some things. So first of all, we need to initialize buffered image. This is a temporary image which we want to create, and we would add in further details. And this rendering hints, we need to include this as well. And we need another color, which is a mid-tone color. So let me quickly define that mid-tone color. So mid-tone color is going to be the black color, but with some transparency. We are going to, as we have talked about the lines and the line noise and the dot noise. So these won't be completely black, but they have small transparency in them. So that's why we need this mid-tone black color. So let me quickly define that mid-tone black. Um, Here we in our captcha items, let's define this and declare this. And now we can define this color as uh, it has 4 parameters, RGB channels and some alpha value. So if RGB is 0, then it means it's a black color, and this one is a transparency, so it can go from 0 to 255. 180 should be somewhere like 50 or 60%. So this is the color we are looking for. So we are basically defining our mid-tone black color. So first of all, we are setting the background. This is the we are creating a fill rectangle for full width and height of white color. So we are creating the background of white color, and then we are choosing giving the graphic context a color of mid-tone black. So then whatever we would draw after this would be colored mid-tone black. And we are initiating a random number, just like we did in our previous function, text captcha. We would need this random function. And here we are setting some rendering hint. Rendering hint, basically, these are some guidelines for to generate our image. We don't need to worry too much about that, but this anti-aliasing is a very important feature. Anti-aliasing makes sure that our image is not does not appear too pixelated. It adds some blur in the images around the very dark pixels, so that it doesn't it doesn't look bad to our eyes, and it looks like a smooth image. So this is just that property which we are trying to add into our image. Then after we have declared this, we also need to define some variables. First of all, we are going to draw we are going to add the line noise, which we, as we saw in our Adobe XD part, that we are going to add some random lines from left right. So that is very easy. Let's add that line noise. So for that, we first of all we would need some. Let me quickly add that and let me explain this. Okay, so we have to have another variable defined, which is called the line noise frequency. So let's define this. Line noise frequency means that how many lines do we need to in our background. So let's define this variable here. And for now, let's define these to be 15. We have 15 lines, and this loop would run, and it would run for 15 times, and this would use the draw line function, and draw line needs to four parameters, x1, x2, y1, y2. So x1 x1 y1 and then x2 y2. So first we start from the left half, x is 0, the left side of the image, and then we on in the y-axis we just get a random number which is in range of 0 to height. So we don't need to add this 0 here. So we just generate a random number from 0 to height, and any number this is going to be our y coordinate for our first point. Then for the second point, we draw it on the other end, which is width. If we traverse the full width of the image, then it is on the other side. And from there on, we generate another random number and we subtract it from the height. So it is just a random point on the other side of the image. So when these two points are joined, then it creates a line, and we know that we would get 15 random lines just like that. And also, in a very similar way, we can add the noise for the dots. So let's quickly add that. So here we can add the. Similarly, we are drawing ovals with radius 1. Basically, oval has two radii, which are its major axis and minor axis. So both are 1. So it would be just a small circle with the 1 pixel radius. And we are just it needs two parameters, x and y. So we are just giving it x based on 0 to width and any random number in between that range, and for height also 0 to height, any random number between that range. So we're just creating that. We also need to have this variable dot noise frequency. So let's quickly add that. And for now, we are going to have much more dots, like 10 times that of line noise. So we are adding 150 dots randomly in our background. So with this is actually background noise. So we have added the background noise. Then we need to start thinking about the text. So for text, let me quickly add the stub. So basically, we need to add the text as well. So for text, we would just add this code. Let me quickly. Okay, so let me quickly explain this and let's add some things which we don't have yet. So first of all, we are setting the color to black, and then we have to define the X increment. This is basically just like in our Adobe XD, we are dividing the whole width of the image into equal segments based on the text length. Whichever we are getting this text, it is 6 characters, so it is divided by 6. We are giving some padding distance. Then we have offset and X offset and Y offset. So basically, these offsets will determine where the text is placed. And we also have to have this font family defined. So basically, for CAPTCHA, we are going to define a new font, which is Times New Roman. This is a very generic font, and our CAPTCHA needs this font. So let's define this CAPTCHA font family. It should be Times New Roman. So we are going to define this CAPTCHA font family. Let's go back to this function and let's add that font here. And we have to determine the font size. So for font size, we are going to, as we saw that font size has some variations. So we have the font size lower and upper limits. Basically, it would determine that what is the range of our font size. So let's define these ranges here. So our lower limit is 30 pixels and our higher upper limit is 60 pixels. So our font can vary from 30 to 60 pixels randomly. So it would determine our font size. Then based on that, we are setting our Y offset, whichever would be the current font size, our Y offset will be adjusted according to that. And we are going to get our current character, which we would be using the increment to get any character from that string. So we would get that current character, and then we would draw this on the screen based on our X and Y offset. So let me quickly tab that. So basically, we would just draw this and sorry, let me quickly grab that. So let's, this would make sure that our string is drawn on the screen. And then we also need to increase our X offset. So our X offset should be increased by our X increment, which we defined earlier. So we have defined this X increment here. We are just incrementing it to the next section. So once this loop is over, our text should be drawn with varying sizes at some point. After we have successfully drawn this, we need to just export this to our image. The whole function of this function's job is to create an image and export it. So we just need to export this. So we would use this function to dispose. It means that we are done with our object, and we have to import this class image.io, and we need to know that we also need to import this file object, and then we need to define this default CAPTCHA path. So we are going to define paths for our CAPTCHA to be exported to. So it will be similar to this one. Let's define this path here in our CAPTCHA settings. So here we can define our path. So our default CAPTCHA path is um, let's call this images, and let's call this CAPTCHA export.png. So it would be whenever we generate an image, it would be placed here in images, and we would need this to read into our object as well. So let's see. Okay, so this is now giving an error because whenever we try to export an image, this we need to handle that exception. This function can throw an exception, which is IO exception, input output exception. So we need to handle that. So we have written this function. Currently, it would generate an image captcha, and uh, it would just create on the default path. So now we need to show that in our UI as well, we where we allocated our captcha image label. So in order to do that, we need to have some helper functions. First of all, we need another helper function which is called draw captcha. So for new captcha, okay. So first of all, let me quickly let me quickly order these variables correctly, and then let's see. Okay, so we had to do some tweaking. First of all, we need to define this CImage object here. So we have defined this image as CImage, and currently it is null. As we are going to create an image, and we have to get that image, and we have to know that if this image is available. So that's why we are using this CImage. Then we create this image with our default captcha path. After we are sure that we have generated an image captcha, we would call this function draw captcha. It would first clear the previous captcha if there is any previous captcha. So for that, we just set our text in input field to be empty, and then we just flush the current image, and we set it to null, and we reset our icon to be empty icon in our captcha image. So this is our clear function. Then we create a new image, and we just mount it on our captcha image label. So this is how we would draw this. Now we have all the tools that are needed to generate a captcha. Here in our click listener handler, we just need to call this function appropriately. So we don't need any the option pane. We just need to have the correct sequence. So if we have done our we have generated our text, then we need to call generate image captcha, and we need to pass that captcha generator dot capture text. We need to pass this into this function, and it is giving us an error. So we have to handle this. We need to surround this by try and catch, because this function throws an IO exception. And after we are done, then we have to draw this captcha. So we would just call this dot draw captcha. So when we call this function in this sequence, it would generate a new text captcha, then it would generate an image captcha, and then it would draw this. So this is let's see if this works. Let me run this, and let me share my screen with you as well. So here let's see. So now you can see this. So we have to generate a captcha, and if we hit this, it should generate a captcha. So let's do this. Okay, so we have got our captcha. We have this text. We have background noise, and we have a varying size of text, and they are shown correctly. Let's try to hit it again. And whenever we hit it, we generate new captchas. So this is nice. This is what we wanted. So this is like 70% of our captcha generation is done. We are generating text, and we can even stop it here at this point. This is fine for our captcha. But as we studied in our, as we saw in our WXP, we need to add some rotation, shear, and some wobble effects. So for that, we need we need to do some more figuring out, and we need to add some more effects. So let's get back to our code, and let's add those effects as well. So Let me quickly try to add those effects. So in our capture generator, we have now a system to generate an image-based capture, and if we just hit refresh here, we would see that we have this captcha export as well. And if we try to see this, it would show the last generated captcha here, which we generated. So this is nice. But we have seen that we are really close. We here in our captcha generation, basically, we need to add some variation here in this function. We have to have some cases. First of all, we need to define that whether we want to add shear effect or not. So we have to define the chance of a character having shear effect. Then we also have to define the wobble effect. Wobble effect is like when we view something through a fishbowl, it appears very wonky and that kind of effect. So I'm just calling this a wobble effect. So we need to make sure that we are getting those. So we have to first define their probabilities, probability of those occurrences. So let's define the frequencies for those, not frequencies but probabilities. So let me quickly define those here in our CAPTCHA generation. So first of all, we would list those in our CAPTCHA properties. So here we are adding two more probabilities. This is the first probability is skew corrected probability. So how often a character can be skewed. And then there is a wobble character probability. So how often a character can be wobbled. So in order to do that, first of all, we would need to change some definition here. So in this draw string, we cannot simply just draw string here anymore. So let me quickly add the definition for our new functions. So in our generation, we have to have three cases. So first of all, we would add the skew effect, then we would add wobble effect, and then we would apply this we would if those effects are not the case, then we would draw this like we are drawing it normally. So let me quickly add that. So instead of this line, we are just going to apply those effects. So first of all, we need to import this affine transform. This is basically a geometrical transform on any object which is 2D, or this is basically a matrix-like effect which is performed on 2D matrices. We multiply the matrices by some number and it performs some transforms. So first of all, we are storing the original transform because we are going to share a character. So basically, we need to know original transform. Then we just add the skew effect. So this skew effect, we just share it. These are very common computer graphics effects. So we are just trying to uh, twist it. We are just trying to, pulling it from one side, just like we showed in Adobe XP presentation. So we are trying to skew our characters, and we also are trying to add some rotation. So basically, this is just a random chance. We just add subtle skew and slight tilt to the characters, and this is based on the chance. So we have our probability defined, and if we are within that chance, we apply this skew effect. And then the wobble effect, we have our probability of wobble effect as defined here as 20%. So 20% of the time, the characters would get a wobble effect, and we have to also write this function. So let me quickly write this function. This is basically the function which causes this wobble effect. So this apply water effect, let's define it above this function. So basically, let me explain this quickly, what happens in a wobble image. First of all, we create in this particular skew effect, we just draw the string and apply some different transformations. But in case of wobble effect, we cannot apply these kind of transformations. We have to draw the image. We have to draw this character image. So we create this character image, and then we apply the transform on this image. So we call this function. We are giving the we are generating a new image. Basically, it's a small image patch, and we are just giving the anti-aliasing directive. And then we, after setting some properties, we have to we are basically drawing this character, and then we have to use that image which we temporarily created, and then we apply the water wobble effect. So how does this function work? This water wobble function basically gets an image, and then it applies sign displacement field. So what is a sign displacement field? Let me just show you. Let me share my screen with you. So here in our browser, we have plotted this function. Basically, this is the function that we are trying to replicate here. This function applies this sinusoidal wave in vertical direction to any object, any signal. So in our case, our signal is our image. So based on these parameters, we have this phase, which is an angle, and this amplitude of wave, and this wavelength of the wave. So based on these randomly generated parameters, it applies this kind of transform to an image. And whenever this kind of distortion would be applied on any image or a character, it would cause it to be look like a wobble effect. So we are applying this on our whatever character gets a water wobble effect. So this is the function written in Java, and it would simply apply this, and then we return this image. So in case we have the wobble effect, it would be applied here appropriately. And finally, we are just if this is not the case, then we just draw the vector normally, what we are doing previously. So let's save this, and let's okay, let me check what's the problem here. Okay, so we just have to save the file with UTF-8 encoding, and nothing too fancy. So now we have applied these effects. Let's test it. Let's run this, and let me share my screen with you. So we have this interface. Now our CAPTCHA would be, we would be able to see some skew and tilts, and also some sort of wobble effect. So here we can see that this has been distorted a little bit. This is like a wobble effect, and this is like a skew effect. So let's see if this we can see much more prominent usage of this effect. So we can see that M is getting some sort of wobble, and let me quickly see. Okay, this is also another example. So P, this letter P is getting some wobbles. And so our first part, which is to generate a CAPTCHA and the image CAPTCHA, this has been done correctly. So now we need to make this functional. We need to know if we submit any text here, then it should properly check if it matches a CAPTCHA or not. So let's quickly implement that. And okay, so first of all, this part, this class, CAPTCHA generator class is nearly done. We don't need to add anything here. We just need to add that method here in our click listener. So here we would need to check for other case. If we get this submit command, then what should we do? So let's add this here. And let me quickly add the definition of this command here as well. So, so let me quickly add that definition. So this is our class. So we just need to give some proper variable names. So this is sp command. And basically, we need to define some variables. So let's first give it the proper name. So we have our input field. And if we don't have any text, then we have to show some warnings and appropriate messages. So uh, let me quickly check that. And we need to import this class image icon here. And okay, so we have to have success image path as well. So let's add these variables. So in our listener, we need some variables. Let me define those. So here in our after our before our constructor, we need to add some variables. So basically, we have to have a success icon. In Java, there is no success code. It's just an information message. So I have designed a nice icon. So let me quickly add that. So let's go back to browser and let's see if we can get our icon. So here in this, I have already defined this success icon. Let's copy this and let's add to our workspace. So here we have added this. Let's get back to our code. So what else do we need? So I think this is all we need. We don't have any error. So let's check if we are able to check our CAPTCHA correctly. So let's run this and let's share my screen. Okay, so if we don't have any CAPTCHA and click submit button, then we are getting a warning, no code entered. Then if we enter something and we hit submit, then we are getting the wrong code message. Okay, and then if we generate a CAPTCHA, then let's generate a CAPTCHA and try to enter the number, enter the code. So let's see if we are going to correctly guess what is the code. So if we submit, okay, I have submitted the wrong code. I think this is not one, this is L. So okay, in case of the correct entry, we get the correct icon and the success message. So our captcha generation is working, and when we submit the correct captcha, it resets. So we have to generate the captcha again. So when we can see that our captcha generation is working correctly, and we are getting different effects, and we are generating the captcha. This one looks a little bit challenging. Let's solve this. So let's see if we correctly figure out this captcha. So, okay, we have entered the correct code. So, as we can see that entering the codes and understanding this captcha is easier for us, but for a machine, it is very difficult. And we might make a next part where we try to write an OCR or optical character recognizer, optical character reader, and we might try to solve this captcha via that. So for now, this is it for our CAPTCHA generation. This is how we generate an image-based CAPTCHA in Java. And if you have any questions, please feel free to ask. The code would be available in GitHub repository. Thanks for watching. And if you like this kind of content, please subscribe and stay tuned. Thank you so much.